Hey everyone, ready for another deep dive? Buckle up, because today we're taking a look at AI image generation, specifically how it's about to get a whole lot faster. Like, imagine creating photorealistic images right before your eyes, in real time. That's what we're talking about today. We're diving into a paper called Achieve Fast Diffusion Image Generation, comparable to Stable Diffusion. And that title alone, woo, it's a game changer. I mean, Stable Diffusion is like a top dog in AI image generation right now. So to hear that this research is claiming comparable results, but way faster, well, that's huge. But before we get ahead of ourselves, let's do a quick recap of the tech that makes all this possible. Diffusion models. Think of it this way. You take a picture, right? And then you slowly add noise to it until it's just a mess of random pixels. And then, get this, you teach an AI to reverse that process. So it goes from that random pixel soup to creating a brand new image. Pretty wild, huh? But here's the thing. These models usually need a ton of tiny steps to create a high-quality image. It's a real-time hog. But the research we're looking at today might have actually found a way to make these models insanely fast without, and this is key, without sacrificing quality.
The secret sauce here lies in something called distribution matching distillation, or DMD for short.
DMD, okay, I've got that. So how does this DMD actually work?
Instead of trying to perfectly copy each and every pixel, DMD is all about capturing the overall style of the images. Think of it like the statistical fingerprint. It's more like teaching a student to really grasp the essence of a master artist's work. They're not just robotically copying brushstrokes, they're learning the style itself.
So instead of getting lost in the tiny details, DMD is like looking at the bigger picture.
Exactly. It's essentially coaching a one-step generator to create images that statistically match the output of the original, much slower multi-step model.
Okay, so DMD is all about efficiency. Work smarter, not harder. But what about the results? Are they as good as the paper's title claims?
They're pretty remarkable, actually. This technique doesn't just beat other speed-up methods. It also generates images that are on par with Stable Diffusion, quality-wise. And the kicker is, it's orders of magnitude faster.
Hold on, orders of magnitude faster. What does that even mean, practically speaking?
We're talking about generating images at a rate of 20 frames per second using today's hardware. Basically, it's real-time image creation.
Whoa, 20 frames per second. That's insane. You could literally watch these AI models create these stunning images right in front of your eyes. The potential applications are, endless. Okay, but before we get too carried away, are there any downsides to this approach? Any limitations we should be aware of?
Well, one thing to keep in mind is that training those separate score function models for DMD can be a bit of a bottleneck, especially when you're working with huge data sets.
So there's definitely room for improvement there, more research to tackle those challenges. But even with those limitations, this is still a massive leap forward in AI image generation. All right, I have to admit, I'm really curious to see exactly how DMD works under the hood. How does it achieve this crazy speed while keeping the quality so high? Let's dig deeper into those technical details in part 2. Stay tuned, folks, because we're going to unpack some of the magic behind DMD. And trust me, it's worth sticking around for.
Welcome back, everyone. Let's dive a bit deeper into how distribution matching distillation works. Really peel back the layers and see how it manages to achieve such a significant speed boost.
All right, time to get our hands a little dirty with the technical stuff. I'm ready to peek under the hood.
So remember how we talked about DMD capturing that overall style, that sort of fingerprint of the images?
Yeah, that was the big takeaway, right? Focusing on the overall distribution, the essence, not getting bogged down in individual pixels.
Right, exactly. And to do this, DMD uses these things called score functions. Think of them like mathematical judges, if you will. They carefully evaluate how well let's call it the student, which is our one-step generator, how well it captures the essence of the master artist, the original multi-step diffusion model.
Okay, I like that. So these score functions are kind of like art critics with a really sharp eye, making sure the student's work matches the master's signature style.
Exactly. And here's where the real magic happens. DMD works by minimizing the difference between these score functions. So by carefully tweaking and adjusting that one-step generator, we can nudge it closer and closer to producing images that have the same statistical fingerprint as the slower model.
So it's like we're fine-tuning the student's artistic technique until their work is practically indistinguishable from the master's.
A perfect analogy. And it's important to remember, it's not just about mimicking the surface level, like copying brushstrokes. It's about understanding those deeper principles, that overall aesthetic that really defines the master's style.
That's amazing. It sounds like DMD is taking a very sophisticated approach to this whole idea of learning and mimicking style.
It is. And there's another really crucial element to this. DMD also uses something called a regression loss.
Regression loss, huh? What exactly does that mean in this context?
Basically, it helps you ensure that the one-step generator accurately captures the large-scale structure of the images. It's like making sure the student not only paints with the right brushstrokes, but also understands composition, perspective, how to arrange elements within the frame.
Got it. So it's not just style over substance. It's about capturing both the style and the overall structure, making sure the student sees both the forest and the trees.
Precisely. It's a holistic approach to learning and replicating. And remember, all of this was rigorously tested. We're talking massive data sets, ImageNet, COCO, 30K, the whole shebang. And the results really speak for themselves.
Yeah, that 20 frames per second achievement while keeping the image quality comparable to Stable Diffusion, that's pretty groundbreaking. I mean, it really opens up a world of possibilities, doesn't it?
It does. And as this technology continues to evolve, we can expect even faster speeds, even more realistic images.
Okay, so we've talked a lot about the technical marvels of DMD, but what about the real-world implications? Where do you see this technology having the biggest impact?
Oh, the potential applications are vast. I mean, imagine real-time character animation for films and video games. Or think about interactive design tools, where you can see your creations come to life instantly. You could even have personalized advertising that adapts to your preferences, right then and there.
Wow, it's like we're on the verge of a creative revolution.
Indeed. But as with any powerful technology, it's important to consider the implications carefully.
Yeah, that's a good point. We've seen how this tech can be used for good, but are there potential downsides, like ethical concerns we should be thinking about?
That's a critical question and one we'll explore further in Part 3. So join us as we delve into those broader implications, what this research means for the future of visual content creation.
And we're back. It's time to wrap things up and really think about what this research means for the future. We've seen the incredible potential of DMD, how it could revolutionize creative fields by making image generation lightning fast. But let's take a step back for a minute. What does all of this tell us about the future of visual content? What does it mean for all of us?
This research really signals a paradigm shift. We're moving away from the days when creating high-quality visuals was this, incredibly time-consuming and resource-intensive process.
Right.
DMD is pointing towards a future where creating stunning visuals could become almost instantaneous.
It's like the leap from painstakingly hand-drawing animation cells to using sophisticated 3D modeling software, right?
Exactly. And as this technology keeps getting better, we can expect even faster speeds and even more realistic visuals.
I mean, imagine the world where you could just describe what you want and boom, an AI generates a photorealistic image or video for you, just like that.
We're not that far off, actually. There are already AI models out there that can generate images from text prompts, and the results are pretty mind-blowing.
It's wild to think how this could transform creative fields, like advertising, filmmaking, even architecture, right?
Absolutely. Think about architects designing buildings in real time, seeing how different materials and lighting affect the overall look instantly.
Or filmmakers creating entire worlds and characters with a few lines of code. It's incredible.
The possibilities really are limitless. And it's not just about these big industries either. This technology has the potential to really democratize visual content creation, giving anyone with an idea the power to bring it to life.
I love that. It's not just about big studios and tech giants. It's about putting the power of creation into everyone's hands.
Exactly. Imagine kids creating their own animated stories or small businesses producing professional-looking marketing materials without needing expensive equipment or specialized skills.
Talk about breaking down barriers. This could unleash a wave of creativity that we haven't even begun to imagine.
It's pretty exciting, right?
It is, but as we embrace all these advancements, I think it's important to acknowledge the challenges they might bring. If creating visual content becomes easier and faster, how do we make sure it's authentic? How do we know what's real and what's not?
That's a really important point. In a world where anyone can create hyper-realistic content, we need ways to verify the source and integrity of that content, especially as technologies like deepfakes get more and more sophisticated.
So we need to be smart about it. We need to develop the tools and the critical thinking skills to navigate this new landscape of visual media.
Absolutely. And, we also need to think about the implications for human creativity itself.
Right, like will AI become a tool that helps human artists and designers, or will it become a competitor?
That's the big question, isn't it? Some people believe AI will augment human creativity. It'll free us from those tedious tasks and let us focus on the bigger picture. But others worry that AI could eventually replace human creativity altogether.
It's a tough question with no easy answers. It feels like the future really hinges on how we choose to integrate AI into our creative processes.
It does. This relationship between human and artificial intelligence in visual content creation, it's something we're all going to have to figure out together.
Okay, so as we wrap up this deep dive, what's the key takeaway you want our listeners to walk away with?
I'd say the biggest takeaway is this. The rapid progress we're seeing in AI image generation, like with DMD, it's a testament to human ingenuity, that's for sure. But it also comes with a responsibility, a responsibility to use this technology ethically and thoughtfully.
We're definitely on the cusp of a new era in visual content creation, an era filled with possibilities and, yeah, some potential challenges too. But ultimately, we all have a role to play in shaping this future. It's up to all of us to ensure that AI empowers human creativity rather than replacing it. And on that note, I think it's time to wrap up our deep dive. Thank you so much for joining us. Until next time, keep exploring, keep questioning, and keep diving deep into the ever-evolving world of knowledge. TREFE.